Hi girls, here's a quick video on 9.5 where we use logs and exponents in equations. We've done a lot of this already. One thing I want to talk to you about is, when we're going to look at log base 10 of something, there's always some argument here, on our calculator, that's log. So we often use that log base 10 because we want to use our calculator, or log base e of something. On our calculator, we have to remember that's ln, okay, little ln. So we're going to use those to solve maybe. So when we use those to solve, we can look at this. We go 3 to the x equals 7. Now I'm going to do something in this process that you haven't learned yet, but I know you learned it in year 10. So what I'm going to do is I'm going to take the log of both sides. I'm going to get my calculator in a minute here, and I thought I had it out, but I'll pause for 1 second. Okay, so I'm going to take the log of both sides. I can use log or ln, it doesn't matter. So I'm going to go log 3x, there's base 10 there if I don't write it, is log 7. And there's this rule that says if you have a power up here, and you have a log, so log 3 to the x, I can bring that x down here. So that can be written as x log 3, x times log 3, equals log 7. And so x equals log 7 over log 3. And then I grab my calculator and I say, okay, I'm going to type in, where am I? Log 7 and the brackets divided by log 3 and the brackets. And that gives me 1.77 about. Now what if I had picked ln instead? What if I had written ln of both sides instead of that? Let me just do it. ln 7 divided by ln 3. Oops. I got the same answer. So it doesn't matter which one you do. This leads us to this kind of thing that I'm 99% sure is on your formula sheet. I was going to look and I forgot. And it's called the change of base rule. And it says, if I have log base a of b, and I want to change it to log base 10 or log base e, that's just log b over log a. It's a really good rule to use when I don't have a calculator. It really doesn't come up until year 12, so I don't want you to worry about it, but you can see that rule kind of right here, that if I had rewritten this as using the big rule as log base 3 of 7 equals x, going from exponential to log form, I could have used the change of base rule right here and said, oh, that's just log 7 over log 3. Okay, so there's lots of different ways to approach these problems. These are all one of them. Okay, let's do a couple solves here. Let's do an egg. You might want to pause and see if you can do it on your own. Okay, I'm going to do log 5 to the x equals log 8. So x log 5 equals log 8. So x equals log 8 over log 5. Or you could have done it a different way. And I want to do it to 3 decimal places. So I'm just going to go, I hope you can see, yeah. Log 8 divided by log 5. 1.292. Okay. The next example I want to do is a little bit different. It's 2 to the 1 minus x equals 6 to the x. That's kind of funky, isn't it? So let me just log both sides. Log 2 to the 1 minus x equals log 6 to the x. Now, the way that I do this, the way that I can do this is by just knowing that rule that this comes down the front. And why do I do it? Because x is in the exponent. So the trigger to you, when you see x as the power, Okay, that's when you do this log on both sides thing, so you can get it out. So when I get it out, it comes out as 1 minus x times log 2 equals x times log 6. And so I'll go 1 minus x over x, I'm going to divide by that, equals log 6 over 2. So this side I just do with the calculator, and I get log 6 divided by log 2, 2.585. So I get 1 minus x over x equals 2.585. Then I might multiply by x, and then add x, and then divide. Sorry, I'm running out of paper, but I'm not going to do anything about it. You see that? So the answer turns out being 0.279. Okay, that's good. I don't think I have anything else. The questions that we're going to do when you come to class are 1, 5, 9, 10, and 11. And that is out of 9.5. Okay, see ya.